All right, here we go, Matsu. I've already filled in all of these notes. Like I usually don't do that, but I already made this video and then the video didn't save for some reason. So sorry about that. Here we go. All right, so 3-8 compositions of transformations. So our question today is if a preimage is rotated 90 degrees counterclockwise and then reflected over the y-axis, what effect will this have on the slopes of the image's sides? See, because what we're doing today is we've already practiced our transformations that we did last year, our translations, our reflections, and our rotations. And now what we're going to do is say, okay, what if I did more than one transformation at a time? How could I tell the difference about it? And remember, when we do these transformations, they're making congruent triangles. That's why it's fitting in this unit where we're looking at triangles that are congruent, and we use side, angle, side, and all that other stuff. But now we're saying, hey, another way to prove that triangles are congruent to each other is if we can prove that there's a transformation between them, because these are rigid motions, and rigid motions produce congruent shapes. So our first one that we're going to look at is a translation. Now, when you look at a transformation, like our examples here that we're going to do today, sometimes just looking at them, it's kind of hard to see exactly what's going on. Now, you can guess, but guessing is probably not a good method. Okay, so what we're going to look at is the slopes, because the slopes are going to tell the story of how these transformations are occurring. The first one's pretty simple. A translation, the slopes are just going to stay the same. Because remember, the translations are where we just take our finger on it and move it up and down, left or right. So for this one, it looks like we're moving it, over to the right and then down. And what we notice is that the shapes are still facing the same direction. So over here, if I had a slope of, I don't know, call that 2/1. Then this one over here would still have a slope of 2/1 because it's facing the same direction. So if I notice that the slopes are staying the same, this might be a translation where all that's happening is that we're just taking it and moving it in a direction, left or right, up or down. Okay, so those are the easy ones to notice, and usually you can see those by just staring at it and you'll see what's happening. Okay, so for this one, reflections, the slopes do not stay the same. They become opposites, meaning that they change their sign. So here I've got a problem here. Let's say this one. This slope goes up 2 and over 2, so that's a 2/2. And then I reflected it over the y-axis. Now when I reflect it, look what happened to the slope. It became negative 2/2. So the slopes became opposites. Positive 2/2, negative 2/2. So they change their sign. So if you see opposite slopes, that tells you it's a reflection. A rotation of 90 or 270 means that the slopes are going to be opposite and reciprocal. So opposite, we said, is changing their sign. Reciprocal adds something new into it. That means the numerator and the denominator are going to switch places. So let's say that you're looking at one and it has a slope of 1/4. The opposite reciprocal of that would be negative 4/1, because opposite means this is positive, this is negative. Reciprocal means we flip the numerator and the denominator. So 1/4 becomes 4/1, which is just 4. Or if we had negative 2/3, opposite means this one's positive. And then we flip the numerator and the denominator. So the numerator and denominator change places. So the opposite reciprocal of negative 2/3 would be positive 3/2. So opposite, one's positive, one's negative. Reciprocal, we flip the numerator and denominator. Now 180-degree rotations are a little bit different. They end up, so I took this shape here and I rotated it 180 degrees. And what I notice here is, okay, this slope, let's just say it was negative 2/2. After a 180-degree rotation, I still get a slope of negative 2/2. And that is what we said happens to translations. But with translations, remember the shapes face the same direction. Now look at the 180 degrees. Are these two shapes facing the same direction? No, they're kind of facing in opposite directions. So the shapes are facing different directions. So if it's the same slope but different directions, then we're looking at a 180-degree rotation. All right, last thing before we do our two examples. Naming a transformation. When you name a transformation, you need to do two things. You have to state the type of transformation that's happening. So our three types that we're working with in this section are translations, reflections, and rotations. So you have to say, is it a translation? Is it a reflection? Is it a rotation? But you can't stop there. You also have to give a direction and distance. So if it's a translation, well, translation, how much? Is it left 2 and up 5? Or is it right 5 and down 6? You have to say which direction it's going and how far it's going. If it's a reflection, well, reflection where? Is it over the x-axis or is it a reflection over the y-axis? So you have to specify its direction and distance. If you say it's a rotation, well, what kind of rotation? There's more than one. Is it 90 degrees counterclockwise? Is it 270 degrees clockwise? Is it 180 degrees? Is it 90 degrees clockwise? You have to say which type of rotation and its distance, like which way it's spinning. All right, so that's what we're looking for when you give your answers. The type of transformation and some kind of direction or distance that's going on with it. You can't just write right 5, left 2. You'd have to say translation, right 5, left 2. Okay, so you have to name the type and then its direction and distance. So let's look at these problems here. So we said that we're going to look at the slopes. So let's look at the slopes of this one. So starting off, I see here that this is the original because that's ABC, and this is the image, the copy, because it's A prime, B prime, C prime. All right, looking at it, some people might go, oh, I think it's a rotation. It looks like it's rotating that way. It's not. Eyeballing these is never a really good idea. Let's look at the slopes instead. So this one goes up 1 and over 1, 2, 3. That's 1 over 3. From B to C, it goes down 1, 2 over 1. That's a negative slope, so negative 2 over 1. A to C goes down 1 and then over 1, 2, 3, 4. So its slope would be down 1 over 4. All right, let's look at the other one. So this one, from A prime to C prime, it's going up 1 and over 1, 2, 3, 4. So that's positive 1 over 4. From B prime to C prime, it's going up 1, 2, and over 1. So that's 2 over 1. From A prime to B prime, it looks like it's going down 1 and then over 1, 2, 3. So negative 1 over 3. All right, so we've got our slopes, and now we're going to compare. So 1/3, negative 1/3. Negative 1/4, positive 1/4. Negative 2 over 1, positive 2 over 1. Those look like opposites because it's the same numbers, it's just one's positive, one's negative. Now, which of our transformations gives us opposite slopes? Slopes are opposites, that's reflections. So this one must be a reflection. All right, so I'm going to think about this. If this is where I'm starting, I can either reflect over the y-axis here or reflect over the x-axis here. But really quickly, when I reflect over the y-axis, I see it's not facing the right direction. Because if I reflect it over here, the B will still be on top over here, and I want B on bottom instead. So reflecting it over the y-axis, not a great idea. Let's see what happens when I reflect it over the x-axis. Okay, so if I reflect this over the x-axis, let's put C one space away down there. So that's where this one would go. B is 1, 2, 3 spaces away. So I'm going to go 1, 2, 3 spaces away here. And A is 2 spaces away. So I'm going to go 2 spaces away here. Now look at the shape of this. After reflecting it over the x-axis, I notice that this thing right here looks like it's the same direction as this one. They're matching up now, but they're not on top of each other, so I'm not done. Remember, we're doing compositions of transformations, so there's more than one transformation to do. So it looks like I reflected it over the x-axis. So that's my first transformation. Reflection over the x-axis. All right, so that's the first step. I gave the type of transformation and a direction or distance, and I went over the x-axis. So that's how we name it. Now that's not enough. I still need to get this triangle over to here. So what I see here is if I take this point and try to move it here, I'd go to the right 1, 2, 3, 4, 5, and up 1, 2, 3. To take this point over here and get it to B, I go over to the right 1, 2, 3, 4, 5, and up 1, 2, 3. It's matching. It's on top of it now. This one, 1, 2, 3, 4, 5, up 1, 2, 3. So all the points, if I go right 5 and up 3, they all line up. So that's what we want to do. We want to get this shape lined up on top of that shape, and that proves the two triangles are congruent by transformation because they're rigid motions, and rigid motions produce congruent shapes. So my last step is after I've reflected it, I now see that I can translate it right to 5 units. So I'm going to say right 5. And then we said up 3 units. So if I take this original, reflect it over the x, and then translate it right 5 up 3, this shape would be on top of that shape, proving the two shapes are congruent. Let's try it again. Next one. Remember, first step, we look at the slopes. From A to B, it's going down 1, 2, and over 1, 2. So that's negative 2 over 2. From C to A here, it's going up 1, 2, 3, 4, and over 1. So that's 4 over 1. And my lights just turned off because I wasn't moving enough. Now they're back. All right, so it's 4 over 1. Everything's going wrong today. So from C to B, I'm going to go up 2 and over 1, 2, 3. So that's 2 over 3. Sweet. We are moving on. All right, now let's look at the other triangle. From A prime to B prime, so this is the copy. It's going up 1, 2 over 1, 2. So that's positive 2 over 2. From B to C, it's going down 1, 2, 3, and over 1, 2. So that's negative 3 over 2. From A prime to C prime, it's going down 1 over 1, 2, 3, 4. So it's going down 1 over 4. Now let's match them up. 4 over 1, negative 1 over 4. Negative 3 over 2, positive 2 over 3. Negative 2 over 2, positive 2 over 2. It looks like what's happened here is the signs have changed and we have switched the numerator and denominator. What do we call that? Those are opposite reciprocal slopes. Opposite reciprocal slopes means that there has been a 90-degree or 270-degree rotation. So I'm going to start with that and say, okay, I need to rotate this thing 90 degrees or 270. So I kind of have to imagine this. If I take this one and go 90 degrees this direction, so that's 90 degrees counterclockwise, will it be facing this direction? Or if I instead move this one 90 degrees down here, will it be facing the right direction? Well, if I move this one down here, the A and B will be over here and not on this side. So we want the A and B up on this part of it because A and B is up on top. But if I go down this way, A and B is going to be on the bottom of the triangle. So I don't want to go 290 degrees clockwise or 270 degrees counterclockwise. I don't want to go that direction. So let's go the other direction. If I go over here 90 degrees counterclockwise, I would see that this AB would move over here and it'd be up on top of the triangle just as this one's up on top. So I'm going to go 90 degrees counterclockwise. So this is a rotation 90 degrees counterclockwise. So where would this be? Well, this is 2, 1, 2, 3, 4. So remember, we could say you can spin your paper. There's a whole bunch of different ways to see a rotation. I just know that if it's 2, 4 here, it's going to be 4, 2 this direction. 1, 2, 3, 4, up 1, 2. So that's where A would show up right there. B is at 1, 0. So if I spin it, I can see that that one's going to be at 0, 1. I'm just switching the numerator or the x and y's. So here's where C would end up being. And then B is 1, 2, 3, 4, 1, 2. So I'm going to go, instead of 4, 2, I'm going to go 2, 1, 2, 3, 4. This is my quick way of doing rotations. Okay, so there's our new shape. And look at it. This shape is now facing the exact same direction as the shape that I want to get to the image. It's now facing the same direction. And now I just need to translate to get this one on top of that one to prove that they are congruent because it's a rigid motion and rigid motions produce congruent shapes. So I can just go down 1, 2, 3 here, down 1, 2, 3 here, and down 1, 2, 3, and now they're on top of each other. So my last step is to say translate down 3 units. We're just down 3. And now the two triangles are on top of each other. I've proven that they're congruent by transformation. The end. All right, do your work.